Hi, welcome to my YouTube channel. Today I am going to explain you about solar cell and also show one random simulation to you and its code. So let's start with index and also please subscribe my YouTube channel if you have not subscribed yet. Starting with the solar cell. What is solar cell? Then we will discuss about various type of solar cell technologies in which we deal about first and second and third generation solar cell. Then for simulation purpose we will discuss about organization of solar cell and photovoltaic effect. Then for simulation environment discussion that we will see in Silvaco ticket simulation. Then for ray tracing and its one method which I have done here in my simulation which is matrix method. Then its subpart solar cell spectra and solar optical propagation model, solar cell extraction. Then most awaited part is a code which I will explain in details here. So let's start with the video. What is solar cell? The photovoltaic effect was first discovered by Alexander Becquerel in 1839. It is one of the most important part in solar cell. Solar cell is a diode that utilizes incident light on it, generates electron and hole pair, and that will generate electrical current. When a photon impinges with sufficient energy on that, this creates an electron and a hole pair in this process, and by this process, electrical energy is generated. So now I will discuss about the various type of solar cell technology. So you can see here there's solar cell. Then we will discuss about we first generation wafer based silicon and second generation thin film solar cell, third generation new emerging technology solar cells. In the first generation we will discuss about monocrystalline silicon solar cell, and then we will discuss about polycrystalline silicon solar cell, and in second generation we will deal about amorphous silicon solar cells, cadmium telluride thin film solar cells. Then also we will discuss about CIJ solar cell also, and in new emerging technologies we will deal about nanocrystal or you can say quantum dots based solar cell, and then we will discuss about polymer based solar cell, and in which we will discuss about also we will discuss about perovskite based solar cell, dye-sensitized solar cell, and concentrated solar cell. So let's start with the first wafer-based silicon solar cell. Wafer-based first generation solar cell. The first generation solar cells are produced on silicon wafer. It is the oldest and the most popular technologies due to higher power efficiencies. The silicon wafer-based technology is further categorized in single monocrystalline silicon solar cell and poly and multicrystalline silicon solar cells. So starting with the single silicon solar cells, single crystalline solar cells, as the name indicates, is manufactured from single crystal of silicon by a process called Joukowski process. Also, there is one more process which is named as float zone technique. Is also the method, but due to expensive in nature and some limitation, we prefer Joukowski process. This large single crystal production precise processing as the process of recrystallizing. The cell is more expensive and multi-process. The efficiency of single crystalline silicon solar cell is lies between 17 to 80%, which is you can say quite good. But due to expensive nature, we switch to polycrystalline silicon solar cells, which we will discuss in next slide. Polycrystalline photovoltaic modules are generally composed of number of different crystals coupled to one another in a single cell. The processing of polycrystalline silicon solar cells is more economical, which are produced by cooling a graphite mold filled containing molten silicon. Polycrystalline silicon solar cell are currently the most popular solar cells due to advantage of cheaper in cost, and also we have to deal with less efficiency, but due to cheaper in cost we prefer polycrystalline silicon solar cell over the monocrystalline silicon solar cell. Then we will discuss about second generation thin film solar cell. So second generation solar cells are economical as compared to first one. Silicon wafer cells have a light absorbing layer up to 350 micrometer, but in this second generation solar cell it is less than 1 micrometer in thickness. So like some of them is I have discussed here cadmium telluride, CIGS, and amorphous silicon. So starting with the amorphous silicon thin film solar cell. It is primitive solar cell that are first to be manufactured industrially, and also it have a benefit of it can be manufactured at low processing temperature. And due to the use of various low cost polymer and other flexible substrate, these substrates requires a small amount of energy and processing time. It has the advantage of wide availability and cheaper cost. So, but disadvantage also as it is has a poor and almost unstable efficiency. Currently, the efficiency of commercial photovoltaic module vary in the range of 4 to 8%. for amorphous silicon solar cell. Now coming to cadmium telluride thin film solar cell, it is one of the leading candidate for development of cheaper and economical photovoltaic device. It has also have advantages of low cost and has a band gap of 1.5 electrical volt as well as high optical absorption coefficient and a chemical stability. That's all are the advantages, but there is a disadvantage also. It has slight low efficiency of 9 to 11%, and also we know that cadmium is a heavy metal and potentially toxic. Also, that will accumulate in a human bodies and animals and plants. So it will be dangerous for environment, our environment, and it is an environmental hazard. And limited availability is a major issue. So that limitation leads us to go to other method, which is CIGS solar cell, that we'll discuss in next slide. CIGS solar cell. CIGS quaternary compound semiconductor made up of copper, indium, gallium, selenium. CIGS are black band gap type semiconductor that will make its efficiency little bit higher to 10 to 12%. Due to sufficient high efficiency and economy, CIGS based solar cell technology is most leading technology for thin film solar cell. Now, it's one more advantage is there, prolonged life with a considerable less degradation, and that will make it's one of the most important candidate for thin film solar cell. Now, third generation solar cell. Third generation solar cell are most promising technologies but are not commercially investigated in details. So there are some types here: nanocrystal based solar cell, polymer based solar cell, dye-sensitized solar cell, concentrated solar cells. So now we will discuss about in details this kind of solar cell. Nanocrystal based solar cell, also known as quantum dots, these solar cells are composed of semiconductor generally from transition metal group, which is group D elements, which are in size of nanocrystal range, made up of semiconductor materials. But there is also disadvantage here that need large space here to make quantum dot solar cell. Quantum dot is crystal size ranging in few nanometer in size. For example, material like porous silicon and porous TiO2, which are frequently used in quantum dots. Now comes to polymer solar cell. Before going to that, I will show you some quantum dots structure. This is, you can see that there is a substrate, there is an electron injection layer, there is a in between there is a quantum dots, and then hole and anode. So you know that anode can be made of ITO, and substrate can be a silver and aluminum, and electron injection and hole layer you can use any layer here, organic layer and inorganic layer, and hole for an organic layer and a inorganic layer. And quantum dots, you know that the material is silicon porous, silicon porous silicon, and TiO2 porous TiO2. So this is it. Now we'll discuss about polymer solar cell. Polymer solar cells are generally flexible solar cell due to the polymer substrate. A polymer solar cell is composed of a serially connected thin film functional layers coated on a polymer foil or a ribbon. It works usually as a combination of donor and acceptor. These are various type of material for the absorption of sunlight, including organic material like conjugate and conducting polymer. So now comes to dye-sensitized solar cell. So a dye-sensitized solar cell. Recent research has focused on improving solar cell efficiency by molecular manipulation. Use of nanotechnology for harvesting light energy. DSSC based solar cells generally employ dye molecules between the different electrodes. It consists of four components: semiconductor electrodes, N-type TiO2 and P-type NiO, dye sensitizer, counter electrodes, carbon or platinum. The DSSC attractive due to simple conventional processing method like printing technique, are highly flexible, transparent and low cost as well. So after that we will discuss about concentrated solar cell. It is newest technology in development. The main principle of concentrated solar cell is to collect large amount of solar cell energy onto a tiny region over the photovoltaic solar cell. It is something based on optics. The converging of sunlight radiation does produce a large amount of heat energy. Concentrated photovoltaics have shown their promising nature in the solar world. Like it have a almost we got a efficiency of 40% in efficiency. Now next is perovskite based solar cell. We will discuss below. Before going to that, we will discuss a schematic of concentrated solar cell. See, you can see that there is a sunlight. onto the lens, and that will converge to the photovoltaic cells, and that will lead to generation of electron and hole pair, and that lead to uh, electrical current or electrical energy, right? So now comes to perovskite based solar cell in next slide. Before discussion of perovskite based solar cell, I will tell you its advantages. So it is a less expensive than conventional solar cell, and it have an excellent thermal stability, and it have almost 31% of efficiency. Now discussion about this perovskite based solar cell. So it is a compound defined by formula ABX3, where X is a halogen atoms and A and B are cations of different size. Perovskite solar cell are recent discovery among the solar cell research community, and possesses several advantages over conventional one. It has efficiency up to 31%. It is going to future of solar cell. It can be predicted that these perovskite may also play important role in next generation automobile batteries, but they have a disadvantage of like low stability and durability, so we have to improve that one also. So now comes to organization of solar cell. So purpose of solar cell. So we know that the purpose of solar cell is to convert the light energy into electrical energy and using photon energy, which we already discussed on previous slides. So we'll only focus on a Silvaco simulation software. And Silvaco offers a suite of software program that can act as a virtual wafer fabrication tool, which help you to like simulate the your designed solar cell here. So now comes to next slide here on photovoltaic effect. So the photovoltaic effect is the process by which a solar cell converts the energy from light into electrical energy. Light is made up of photons. When a photons is absorbed by a matter such as metal, photons provide the energy for electron to move to higher energy states within the material. And however, the excited electron return to their original energy state, and that lead to release in energy. So this is a photovoltaic effect, and now we will discuss about Silvaco ticket simulation. So coming to the first slide, ray tracing. It is one of the important to explain this here because it will be important to do simulations in Silvaco. So optoelectronic device simulation is split into two distinct models that are calculated simultaneously at each DC bias point or transient time step. So optical ray trace using real component of refractive index to calculate the optical intensity at each grid point. And the second is absorption and photogeneration model using the imaginary component of refractive index to calculate the new carrier concentration at each grid point. So this is one of the important thing. Remember that why we need .nk file here. So now coming to the matrix method. So matrix method presents a fast and accurate way to simulate electromagnetic wave propagation through a layered medium. Among a variety of approaches to matrix theory, the most commonly used are the characteristic matrix and transfer matrix description. So the structure of a multi-layer completely determines the statistic of the this multi-layer. And the transfer matrix also contains information about media or both sides of the multi-layer. To enable transfer matrix method for calculation of intensity, we need a statement tr.matrix parameter in the statement. So now comes to formula part. I will not going to read this, like you can read these lines, okay, which is also explained here. So you can like understand like this. If you apply a zero voltage, the current a zero node voltage, the current is ISC, and if you apply zero anode current, or you can say cathode current, so it is the VOC, where the voltage is VOC. So this is a VOC and this is a ISC, and the maximum power is VMP into IMP. So P max equal to IMP into VMP, and form factor is P max upon ISC VOC, and also you can make it in a different way also, IMP into VMP, and divided by ISC into VOC. And eta is efficiency, which is P max upon my P in. Here I will show you also in the extract format these codes, which will be helpful for you to find these in Silvaco simulations. Okay. Now solar spectra. You can read this slide also, but the thing I have explained in the above slide is this only this statement. So beam number one is AM 1.5. So AM 1.5 is used to give the intensity of a light of solar cell, in the your solar cell simulations. Okay, so beam number one beam is applied a solar cell, which is a terrestrial solar cell is AM 1.5, and which wavelength is started at 0 0.3 micrometer and also 300 nanometer, and which wavelength is end at 1200 nanometer, and I have sampled the wavelength in 50 times, so you can say it is divided in 15 times samples, and so this will help you to apply a beam of light on the solar cell you have designed. Okay, and now comes to the solar cell extraction. Solar cell extraction. These extraction methods are solution strategies placed in your input DAC after defining the device structure, physical model, and the optical source as described in the previous section. Typically, the first step in solar cell analysis is to illuminate the device. So you can turn on the illumination by assigning the beam intensity on solve statement as follows. Solve B1 equal to 1.0. So B1 is equal to 1.0 means that you applied a one solar intensity to the device, right? And if you like encounter any convergence issue, then you have to apply in the form of ramp, which I have defined below. You can see that solve b1 equal to 0.01, solve b1 equal to 0.1, and solve b1 equal to 1.0. That will help you to eliminate the convergence issue in your simulation if you face like convergence issue with the statement solve b1 equal to 1.0. So now the most awaited part is let's go to the code. Okay, I will give you the code here. So this is the code part. So starting with the go atlas, to run the atlas command we have to use go atlas, and then we use a variable name width whose value is 1e11, and which I have used here also, and also in the below. And this is a mesh auto command, so that's why I don't have to use the ymesh here. You can see that, and the ymesh thing is coming from this statement, region statement. Then I have defined the electrode statement. You can see that anode is ITO and its coordinate, and cathode is silver and its coordinate, right? And then I have defined the CdS, like band gap energy, permittivity, affinity, conduction band density, valence band density, and carrier lifetime, right? So also one more thing, I have defined the index.file as solar0.nk. This file may be different in your one, and you have to like find your name which is for this file. Okay, and I have then I have defined the ITO .nk file and the silver, and then I have defined the material Jadano and its band gap energy, permittivity, affinity, mobility, and conduction band density, and carrier lifetime, right? Then I have defined the supra file. This is also a .nk file, and then I have defined the doping for region 4 and region 3, and then models SRH, and added Fermi, BGN. To print these models, I have used the print statement. Then I have used the contact name anode, and its work function is 5.75, and reflect 0.5 to reflect from the surface of the anode, and contact name cathode, work function 4.3. Then I have used the method Newton trap, max trap equal to 10. Then I have used the output statement here. Then I have used the interface between semiconductor and its coordinate and its surface recombination velocity, right? Then I have used the surface tracking here. You can see that, and Lambert as a mathematical function for that. And beam number one, AM1.5G for sunlight. And the point where the beam is coming is X origin, Y origin, and angle is 90 degree. The beam angle is 90 degree, and the try dot met is matrix method, and minimum power and reflect is whole all the statement. Then I have used the solve init and solve prev here. Okay, then I use the solve b1 equal to 1 for illumination of the light for one sunlight, and then I use a log out of a file named how hi.log, and then I use a statement solve name anode equal to anode and v node, v step and v final for getting the IV characteristic, then the log off, then I run this hi.log here, and you can see in my like below, you can see that, and then extract init, and here I have collected the efficiency form factor and VOC and JSC here. You can see that. Then this is a structure file which you got from this statement. and the quit. That's all from the my coding part, right? So now coming to the result part. So this is IV characteristic. Okay, this is IV characteristic you got this IV characteristic you got, and this is the photo generation rate. Okay, and this is this is the structure. You can see that there is air is here, and this is ITU, this is ZNO, this is CdS, this is a silver layer. Okay, so this is all, and this is the efficiency which I got here. You can see that the form factor here, and the VOC and the JSC. So this is all from my side, and if you find any problem in my code, or if you have any problem in understanding my code, please contact me from the link given in the description, and also you can write your question in the comment box.